Hello everyone. Today we are going to understand first the Fleming's left hand rule. It is the part of your chapter called effects of electric current, electricity and effects of electric current. Okay. So as you can see, here we have the left hand of the human being. Here we have thumb, then we have index finger and a middle finger. We have to stretch all these three fingers in such a way that they must be perpendicular to each other. As you can see, here it is 90-degree angle, here also 90-degree, and here also 90-degree angle have to form. Okay, then we can say that all these three fingers are perpendicular to each other. Is it? Then,
Yes, sir.
yes, then if conditional, it is the conditional one. If middle finger shows the direction of flow of current, index finger shows the direction of magnetic field, then the thumb will show the force acting on a conductor. Okay, this is the Fleming's left hand rule. Understood?
Yes, sir.
Yes. So this rule is called as the Fleming's left hand rule. According to this rule, the left hand's thumb, index finger and middle finger are stretched in such a way that they are perpendicular to each other. Okay, if index finger shows the direction of flow of current, direction of magnetic field, middle finger shows the direction of flow of current, then the thumb will shows the direction of force acting on a conductor. Okay, so this is the effect of electric current, magnetic field and the force acting on a conductor. Okay everyone, this is called as beta Fleming's left hand rule, and on that basis our electric motor works. Okay, electric motor is being designed on the basis of Fleming's left hand rule only. Okay, so I want everyone had to take a screenshot first and then we will start the electric motor.
Done, sir.
Okay, any doubt here?
No doubt, sir.
Okay, now we are going to understand about the electric motor. It is very important. Okay, we are going to start the electric motor. So first we have to understand what is electric motor. So electric motor is nothing but a device which converts electrical energy into mechanical energy. It's called as electric motor. Okay, it is the device which converts electrical energy into mechanical energy. That device is called as beta electric motor. Understood?
Yes, sir.
Okay. Now we are going to understand about the construction of electric motor. So as you can see here, right in front of your screen, this is the electric motor. Okay. The electric motor works on the principle that the current carrying conductor, when placed in a magnetic field, it experiences the force. It experiences the force. Due to that force, okay, electric motor works. Understood?
Yes, sir.
So now we have to understand the construction of electric motor. So this is called as, as you can see here, this is the way how electric motor looks like. So this is the internal part of electric motor. Okay, and it works on the principle when that magnet or that current carrying conductor placed in magnetic field of any strong magnet, then it experiences the force, and due to that force, that particular rotor, as you can see here, it start rotating, and we can use that rotation for many other purposes. Okay, so here we have the in construction the north pole of the magnet, here we have south pole, Here we have that A, B, C, and D is nothing but the armature coil. Okay. This is called as beta axle. Over here we have the axle. Okay. And this is called beta split ring. Okay. That split ring is just fitted over the axle, and here we have the carbon brushes. Here we have carbon brushes. Another side we have the same structure, which is nothing but the split ring and carbon brushes, and we have connected these carbon brushes, okay, to the external source of electricity over here, and we have used the switch also in order to switch on and switch off the current in a circuit. Okay, so this is the construction of electric motor. Understood?
Yes, sir.
Okay, now we have to
Sir?
understand. Yes, beta.
Sir, when the coil rotates, we can see that it is attached to the brushes. So when the coil rotates, the whole setup will also rotate with it, right, sir?
See what happens here due to rotation. Okay, due to rotation, that split rings rotates here. Split ring.
Yes, sir.
Okay, that carbon brushes remains stationary. Okay, we will understand that. I will show you the video for that also. Don't worry.
Yes.
Yeah. So first we have to understand each part of the electric motor. So first we have armature coil. ABCD that we have gone through that, which is nothing but the armature coil. It is the rectangular shape. Okay, it is a rectangular shape loop of a copper wire. That copper wire is again insulated copper wire. Having a resistive coating is called as insulation. Then we have second component of electric motor is the strong magnet. The armature coil is placed between the north pole and south pole of the strong magnet, okay, like the horseshoe magnet. We have already gone through the diagram in construction, is it?
Yes, sir.
Yes, sir.
Yes. Okay. Next we have split rings. Next we have split rings. Third component, the two holes of the ring P and Q. Okay, here we have named them as P and Q here. Okay, here this is the P and here we have the Q. And B1 and here we have B2 are nothing but the carbon brushes. Here it is given X and Y. Huh? Okay, so split rings are nothing but the two holes of the rings P and Q have resistance coating on the inner side. Okay, they are having resistance coating on inner side only, not outer side. Outer side is a good conductor. It is made up of the good conductor, so that from carbon process current can flow there. And the conducting surface on the outer surface. The outer surface is acting as a conductor and inner surface acting as an insulator. Then we have carbon brushes. Carbon brushes are again very important. Two stationary, see, carbon brushes are not rotating. They are stationary. Carbon brushes X and Y, generally we used to take B1 and B2, are connected to the outer side of the split ring. Then fifth component we have the battery. The battery supplied the electric current to the armature coil. Okay, so this is the construction. Okay, this is the construction of electric motor. Understood?
Yes, sir.
Yes.
Okay, now we have to understand the working of electric motor. So how electric motor works, first we have to understand, but for that we have to go through one video first and then we will go through the theoretical part.
Do you know how an electric motor works? An electric motor converts electrical energy to mechanical energy. An electric motor consists of a rectangular coil of insulated copper wire. The coil is placed between the two poles of a magnetic field. The ends of the coil are connected to the two halves of a split ring. The inner sides of these halves are insulated and attached to an axle. The external conducting edges touch two conducting stationary brushes. Current in the coil enters from the source battery through conducting brush and flows back to the battery through the other brush. When we apply Fleming's left-hand rule to find the direction of the force on a current-carrying conductor in a magnetic field, we find that the force acting on arm AB pushes it downwards, while the force acting on arm CD pushes it
Upward
upwards.
direction.
Thus, the coil mounted free to turn about an axis rotates anti-clockwise. At half rotation, Q makes contact with the brush X and P with brush Y. Therefore, the current in the coil gets reversed and flows along the path D, C, B, A. The reversal of current also reverses the direction of the force acting on the two arms AB and CD. Thus, the arm AB of the coil that was earlier pushed down is now pushed up, and the arm CD, previously pushed up, is now pushed down. Therefore, the coil and the axle rotate half a turn more in the same direction. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil and the axle.
Download Spark Learning app.
So now we are going to understand the theoretical part of working of electric motor. First point here we have, when the circuit is completed, the current flows in the branch AB on the loop from A to E. It is shown in the diagram, okay, through the carbon brushes E and F. Generally, the carbon from here, see A to B, okay, through the carbon brushes here we have X and Y. On the picture we have X and Y. Since the direction of magnetic field is from North Pole to South Pole, according to the Fleming's left-hand rule, the force exerted on the branch AB on downward direction, whereas on CD in upward direction. Okay, but after complete their half rotation, their position will changes with respect to the magnetic field. Okay, thus the loop of the axle starts rotating in anti-clockwise direction. After half rotation, the current in the loop starts flowing in direction, it is DCBA. Initially it was ABCD, but now the current is flowing in the direction CDBA. Therefore, the force is exerted on the branch CD in downward direction and on branch AB in upward direction, and the loop continues to rotate in anti-clockwise direction. Okay, so again, that after half rotation, in every half rotation, the direction of flow of current changes, and accordingly that coil, armature coil, continues rotating in anti-clockwise direction only. Okay, and that direction, that rotation can be used for the different purposes. Okay, so this is the way how electric motor works. Okay, everyone.
Yes, sir.
Yes, sir.
Yeah, so this is the electric motor. Thus, the current in the loop is reversed after each half rotation, and the loop of the axle continue to rotate in anti-clockwise direction, and that rotation can be used for many other purposes. Okay, everyone, any doubt here?